um, to provide energy to the customers. So even though this is, you can think of this as rotating, this is acting as a water wheel. Could be a water wheel, right? It can be, say, if you have a way to turn that with a blaze like wind blades, or if you can have a machine or a turbine, right? So this is basically, once again, the prime mover. They, by the way, they're electrically, they're not, this one right here is not, it's not connected to anything. This is what's going to rotate that and convert this mechanical energy coming out of the prime mover, right? Into an electrical energy going to that load. That's basically what we're doing, right? So it's this is what we call it energy conversion. That's the course that you do, right? You're converting mechanical to electrical energy. Obviously, in real life, that's not the case. You're not going to use the synchronous generator to move a DC, right? And by the way, this really doesn't exist anymore. You can maybe you can say a DC machine, but they're probably very cheap for now. On your electric vehicles, if you have an electric vehicle, you have a DC machine, but not like the ones we have right now. They're much different, but kind of the same concept. So what we're trying to do is we're gonna start by adjusting the field current. That's what do you call part A. So with no load, basically what we're trying to do is we're trying to start this machine and then control this current right here, okay, so that we can get some sort of voltage out of this. As a matter of fact, I want you to do this. Don't move anything. Just put a voltmeter and start rotating it, and you'll see that there's voltage being developed right by your hand. But you're replacing your hand by an actual machine, right? So you're generating electrical energy. So the first thing, and that's going to be kind of what you're doing here in the first plot. You're going to be adjusting the field current, on the rotor on the synchronous machine, right? And what you're going to be doing is you're going to increase with this 120 volts AC until you get to about 0.4 amps. And it tells you there, you can read that. Or until you get this VT right here, or the terminal voltage, which is the voltage across here, to about 150 volts, right? You said, okay, I adjusted my field current, everything looks good, there's no load, I get about 150 volts out of my DC generator, and then so everything that you have done so far, there's no load. This is zero, right? Then you're gonna shut everything down, and you say, okay, my prime mover is adjusted, I have the right field current. Then what you're gonna do is you're gonna come back, and now you're gonna start placing loads across this. And you're gonna go from 200, 100, 75, 66, all to 50, right? So you're gonna be decreasing the load that the machine sees. This you can think of as, oh, these are, I'm gonna say 1 ohm per customer, 200 customers, 100 customers, 75, 66, 50 customers, right? That's this second plot right here. This is basically, once again, I'm starting at this point, applying the load, until I get about somewhere around 2 amps, right? So that's the information you're gonna capture. The connections right here, you just gotta look at them. This is the sources. So you have 1, 2, and 3. This is 8 and neutral, and you're gonna need 7 and neutral. Okay. So again, this, and this is on your power supply, right? That's what you're gonna be doing. And it tells you step by step on how to do how to connect them. Remember, part A, you need the fluke meter right here, because you're measuring the field current going into the rotor of the synchronous machine. And you need the terminal voltage. So field current versus terminal voltage. Then you're gonna take this fluke meter and you're gonna move it here. You need a voltmeter right here, by the way. You're gonna move it here So you're gonna remove this, you're gonna put this directly now, and then you're gonna start adding these loads one at a time. So there's 5, right? 1, 2, 3, 4, 5. So this one is load current versus terminal voltage, right? And you're gonna go through it. And next week I'm gonna just go over a little bit of the theory. But basically, one of the things that we're looking for is this equation is VT is equal VA. So VT stands for terminal voltage. What is the generator seeing across? What is the voltage the generator, sees across? And of course, right, as you load a generator, the voltage comes down, right? Comes down, comes down. So that's what we're interested on this terminal voltage. That's what we're measuring, sorry. There is an EMF or electromagnetic force that is developed inside the machine, but there's no way you can measure that, right? Like, how in the heck do I measure that? I have the internal resistance of the machine. I know what the terminal voltage is. I have this, but there's no, you have to take the machine apart and find a way to get that EMF out of the machine, right? It's not possible. So how do you do that? You use this data, and the lab shows you how to determine what the terminal voltage will be, or what the EMF that is being produced by the machine. That's really the ultimate goal. It even tells you when you turn it on. Look, once you're set up, don't touch anything. It says just once you establish the field current at this 150 volts terminal voltage, shut it up and don't touch anything, right? That being said, you might find that as you're putting load on the DC machine, the synchronous machine says, I don't have enough force to give you. I need a little more power. So it's okay for you to adjust the field current on the synchronous machine. Just adjust it so, and you'll hear it, right? You can hear when the prime mover says, I don't have enough power to push that DC generator to supply these customers. You're gonna hear it's gonna start rattling. If you adjust the field current, basically what you're doing by adjusting the field current, you're increasing the load. You're putting more water on the water wheel, or you're putting more steam on the turbine, right? So you're generating more energy. So you can move it around a little bit if you hear. But if the machine runs really smooth and you don't hear any erratic movement, don't touch the field current. Okay? Make sense? Yes. You can, as I say, you can read the lab, and it tells you step by step how to go about it. And then I'm gonna come back next week and I'll draw some stuff right here, some equations. I'll go over in more details of the theory of what we're doing. But does it kind of make sense, like in a big picture? Mm-hmm. All right, that's what we're doing. Yeah. So you're gonna need a belt. You're gonna need two synchronous and a DC machine right next to each other. They're gonna be coupled with that belt. When you're ready, let me know. We can power it up. Oh yeah, one thing. The other thing is there's a switch. Man, there's a switch and you have a load. Basically, once you get the machine running, this variable resistor, you don't want to stop the machine and then put a new load. Stop the machine and it can skew your data. So what you're gonna do is you're gonna create. Let me see. This one you have. This one you have. This one you gotta build. This one you gotta build. This one you gotta build. So you're gonna put 200 ohm load on the machine, right? And then you take the measurements that you need. Then you're gonna turn it off. Then you're gonna put 100 and you're gonna turn it on. And take the measurement. You turn it off. You put the 75. Blah blah blah. Do it make sense? Okay. So because once again, if you stop everything and you said, I'm gonna shut everything off and I'm gonna connect the load. I'm gonna start again. As I said, you should get numbers that are close, but your line might not be as good as if you just go through the process, okay? All right, let's go. Let me see. It shouldn't take you that long. It looks a little bit intimidating, but you're gonna see that it's actually a lot easier than the last one. The last one was kind of weird. This one is a bunch of followers. So you're gonna need a Trump. Yep, there you go. Go for that. So did you talk to